Lesson 885, Filling Cubes, Edge Lengths, Volumes, and Cube Roots. In this lesson, you'll understand that the cube root of A, or with the notation, that cube root with the radical sign with A underneath, means the edge length of a cube whose volume is A cubic units. You'll also use cube root notation to represent the edge length of a cube given its volume. So we're on page 177, taking a look at this lesson, and we're just going to jot down those two learning targets. Explain the meaning of a cube root. And let me show you some notation. Like if we had the cube root of a number, let's say the volume of that cube was 35, in terms of its edge length. The edge of the cube. And secondly, identify the two whole numbers a cube root is between. Just like we did with square roots, but the numbers are just going to be a little different. So you'll see a lot of similarities, E-T-W-E-E-N, between the previous lessons and what we're doing here with a cube. Before we dive into this information here, I think it's going to be helpful to do something that we did in class. I want to just fill out this information. And now we're talking about a cube and looking at the relationship between the length of the edge of the cube that I've highlighted here in blue and the volume of the cube, which is if we were to fill it up with water or sand or whatever, that's kind of highlighted in pink there. So for example, if I have a number line where 1, 2, 3, 4, and 5 represent possible lengths for the edge of a cube like this, if I wanted to find the volume and I knew that this length was just 1, the volume of a cube with an edge length of 1 would be just 1 times 1 times 1 again. So I'm multiplying 1 by itself 3 times. So the volume of that cube is 1 cubic unit. So it's easy enough to generate the other volumes. If this was 2 by 2 by 2, I would multiply those edge lengths together and get 8. Don't confuse this with 2 plus 2 plus 2. This is really 2 cubed. That's why they call it cubed, 2 to the third power. And we can continue on with 3 times 3 times 3. The volume of a cube like that would be 27 cubic units. 4 times 4 times 4, or 64. And 5 times 5 times 5. We could go on, but the numbers start getting really large, so I'm just going to leave it here for a moment. So above this number line, I've got what the volume of the cube would be. But sometimes in the homework, you're going to be asked for the length of the edge of that cube. And that's really where we started to find the volume. 1 times 1 times 1, 2 times 2 times 2. These were the edge lengths. But we're going to do one more thing. To represent these edge lengths, actually I'm going to start down here. Another way to say 5 is with this cube root notation. 5 is the same as the cube root of 125, where this is the volume of that cube. So the cube root of 125 is 5. That just means if I know the volume of a cube is 125, the length of one side would be 5. And I could do that for all of these. The cube root of 64 is 4. The cube root of 27 from up here is 3. The cube root of 8 is 2. and the cube root of 1 is 1. I'm going to circle these just to distinguish them a little bit. So having this number line is going to help us when we're doing some estimating later. So let's go back up to the top. And we might have to scooch up and down to look at our number line. So let's say we have a number like the cube root of 17, and we read that just like I did, cube root of 17, kind of like we're reading from left to right. Say cube when you see the 3, there's the root, and 17. The cube root of 17 is the edge length of a cube that has a volume of 17. I really wish that they had made this match up a little bit. So let's say the volume is 17 inches cubed. Okay. So this number, oops, I should do that in blue to match my number line down at the bottom. This number is the edge length of that cube. So if the volume is 17, the length of one edge is the cube root of 17. Well, let's go ahead and do some approximating. We can approximate the value of the cube root in a similar way that we did with square roots. If I'm looking for the cube root of 17, well, I can't think of anything that I can multiply by itself a third time to get 17. But I can compare it to what I see down below. So if I'm looking for the cube root of 17, had a little hiccup in the recording, so I had to fumble a little bit here. Sorry about that. But if we're looking for the cube root of 17, let's come down below to this little number line that we had before. And I can see that the cube root of 17 would have to fall, well, between the cube root of 8 and the cube root of 27. So the cube root of 8 is 2, and the cube root of 27 is 3. So the cube root of 17 must be between those two numbers, between 2 and 3. Let's move back up top and try to remember that. So the cube root of 17 is more than 2 because the cube root of 17 is more than the cube root of 8. We knew the cube root of 8 was 2. That was pretty. And the cube root of 17 is less than 3 because the cube root of 17 is less than the cube root of 27. The cube root of 27 was 3 because 3 times 3 times 3 equals 27. And I'm here to tell you that the cube root of 17, if you were to fiddle around with it, is about 2.57. Because if I took 2.57 and I multiplied it by itself and by itself a third time, I get something that's pretty close to 17. It's never going to be perfect because 17 is not a perfect cube, but we can approximate it. So let's get used to using that notation for the exact edge length of a cube by looking at this table down here. And we'll get some more practice with our number line as well. So if I know the volume of a cube, down below I have that kind of highlighted in pink, then the exact length of the edge of that cube is going to be the cube root of that volume. That represents the number that I can multiply by itself 3 times. This whole expression represents that number. Let's look at our number line and see if we can figure out about what that number would be. Well, the cube root of 60 looks like it would have to be between these two perfect cubes. Here's 64, must be a little less than that. So between 3 and 4 is going to be roughly where that number falls. The cube root of 60 is some number between 3 and 4. Let's go in the other direction. Here, we're given the exact edge length of a cube. That's going to be something with a volume of 4. So the number that I can multiply by itself a third time to get 4 is probably going to fall between these two numbers, between the cube root of 1 and the cube root of 8. It's going to be a value somewhere between 1 and 2. And finally, let's go back to having the volume. I know the volume is 25. There's some number that I can multiply by itself 3 times to get 25. Now don't confuse this with the square root of 25, where I'm just taking a number and multiplying it by itself. I need a number I'm multiplying by itself a third time to get 25. And if I look again down on my number line just to estimate, the cube root of 25 seems like it's a little less than the cube root of 27. So somewhere between 2 and 3. And that just about does it. I told you I had a little hiccup in my recording earlier. I'm going to go ahead and answer this summary question. If I had to approximate the value of x, if I knew that x cubed equaled 81, or x times x times x equaled 81, well, x times x times x must represent the length of the edge of that cube. Because when I multiply it 3 times, that gives me the volume. So if the volume is 81, then the length of the edge is the cube root of 81. And one last time, we can use our number line to see that the cube root of 81 must be some number between 4 and 5.